about a couple different things on here. Um, Adding on to what we did yesterday with increasing and decreasing and really briefly talking about what a relative extrema looks like, we're going to do a little bit more work with it. The first thing I want to talk about is this idea of is what we refer to as a critical number. And a critical number, as we're going to define it in calculus, is an x value where the first derivative equals 0. So if you think about like when we think about what this looks like, if x equals c, c is a critical number. If f prime of c is equal to 0. So that's how we're going to define a critical number. So when we think about when you're asked where is there a critical number, this is what you're going to be asked about. Now, I'm going to create a thing called that I use as calling it the chart. Okay, so I've termed this the chart, and we're going to start with the chart, and I'm going to label a couple things here. So what I'd like you to do, just for this first layer of the chart, and we'll adapt on this further throughout this unit. So I'd like you to make something that looks like this. And I want you to label this f of x, and I want you to label this f prime of x. Okay? And what I want you to think about on this is I want you to kind of think about when we kind of talked about it yesterday, when f is increasing, f prime is positive. So think about a graph going up. Its slopes are positive. Then when you have a graph that is decreasing, that's where f prime is negative. Sorry about my spelling there. Is negative. So a couple things that happen when you go from an increasing function to a decreasing function. So think about drawing a graph that's increasing to a graph that's decreasing. That's where we get what's called a relative, or sometimes it's referred to as a local maximum. Okay, so if you think about a graph going from increasing to decreasing, so you're going from this first step to the second step, you're getting a relative maximum. Well, what that means is if you have the first derivative graph and you figure out where the first derivative goes from positive to negative, that's where a local maximum is going to be produced. So when you go from line 1 to line 2, that's a local maximum. If you go from the bottom line to the top line, so you go this way, this is where you're going to have a relative or local minimum. Okay, so that's where you're going to have a relative or local minimum. Now, let me show you a couple of examples, and we'll talk about this. And so I want you to have this chart next to you when you do this. So pause it and get this chart next to you so we can talk through this. So I want you to look at determining these features. We did this yesterday. This is the graph of f. It's really important to note that this is the graph of f. If you don't note that that's the graph of f, you're going to be in a difficult place when you look at this. So because you're not going to know what you're looking at. So this is the graph of f. So when we're looking for the local maximums on f, remember yesterday we talked about that being peaks in the graph. So in this case, -4 and 3. -4 and 3 generate local maximums. Okay. Determine all the intervals. That one's not going to be helpful for today, so let me do a different one. Those are pretty easy. Determine all the intervals on which the graph of f is increasing. Now, f is increasing when it's going up. It's going up from -9 all the way to 5. Or sorry, all the way to 0. So if we do -9 all the way up to 0, and then it's also going to increase from 5 all the way up to 9. And so it's increasing, it's going up. This graph is going up. Now, here's the key: is what happens if you're not given the graph of f and you're given the graph of f prime? How does that change? If you look at this one, this graph is saying this is the graph of f prime. So this is the slope. So now we're given this part right here. Okay, so now we're given this part right here. And on this one, it's saying the graph of the derivative is shown below. Determine the values of x, if any, at which f has a relative minimum. Now, if we're going to have a relative minimum, go back to your chart. Relative minimum occurs when the derivative goes from negative values to positive values. Well, if you look at that, these are negative values before 1 and positive values after 1. So 1 produces a relative minimum because f prime goes from negative to positive. This right here is when AP asks for a reason or a justification, that's what they're asking for. They want you to justify by making that statement. Now you get that statement from the chart. You get this statement from the fact that we're going from negative values up to positive values. Okay, so let me look at a different one. Now, relative extrema. Just so you know, relative extrema are relative minimums or relative maximums. That's what relative extrema are. So when it's asked, the graph of f prime is given. So again, this is the graph of f prime. Determine the x values, if any, at which the function f has a relative extrema on this interval. Well, notice this graph goes from positive values to negative values. That would be a relative maximum. -5 is one of them. Notice where they're going is it's where this graph is crossing the x-axis. -2 is another one. There's another one over here at 3. And finally, you kind of go to 7, you go, oh wait, but 7 might be a critical number because the derivative is equal to 0. But it's not a relative extrema because it doesn't cross the axes. So it's really, this is a relative maximum, this is a relative minimum, this is a relative maximum on the graph of f, because this is the graph of f prime. So again, we're going to be given this column right here, the f prime column, and then asked to determine things about the f column. Okay, so if you're asked when f is increasing, and this is the graph of f prime, if f is increasing, f prime has got to be positive. So we need to figure out when f prime is positive. Well, isn't f prime positive from -9 all the way to 0? Now there's going to be a little bit of a trick here, and I think that Delta Math is going to do something maybe a little differently than what I am going to do, because I'm not going to include 0. But I think they're going to ask you to include 0. There's a lot of debates on what's happening on this. I think that for the sake of doing this, I'm just going to include 0 because I think that that's what they're going to ask me to do. And the idea is Because f prime is positive all the way up to 0, when used to the idea of limits, that would mean that f is increasing all the way up to the value of 0. So it's really looking at a one-sided limit. So that's why we're including 0 on that. Hopefully this makes sense. Jump back on Zoom or come back and we'll talk more if this doesn't. Good luck.